Good afternoon. Welcome to Resilience, a Healthcare Design Imperative. And my name is Robin Gunther. I'm an architect with Perkins & Will, and I am joined today by three panelists. I'll let each of them introduce themselves. Casey, start with you.
Good afternoon. My name is Casey Woods. I'm the Chief Operating Officer for the University of Oklahoma Medical Center in Oklahoma City.
Julie.
Hi, I'm Julie Frazier. I'm with Perkins & Will out of the Dallas studio, and I'm also a co-director on the firm-wide Resilient Task Force.
And I'm Doug Calhoun. I'm a Senior Vice President with WSP located in Dallas, Texas.
So certainly Texas, and by extension Oklahoma, has dominated the news cycle in the past few weeks with the extreme cold. And it has again brought into focus the imperative for considering resilience in the design and operation of healthcare campuses and healthcare facilities. So in a sense, I hope we get the award for being the most relevant session in today's, in the conference over the next couple days. But my own journey to resilience really began actually when I worked on a project in 2007, 2008, on the heels of Katrina for a hospital client in the Northeast that was really, had watched actually a lot of the film footage coming out of Katrina of hospitals evacuated, people throwing furniture through windows of buildings, and basically said, that's a movie that I don't want to be in the future, and really took it to heart. And incorporated a lot of resilience measures into the Spaulding Rehab Hospital on the Boston waterfront. In 2014, I had the pleasure, so to speak, to work with the Department of Health and Human Services on a climate resilience toolkit for healthcare. And one of the first things that we did in developing that toolkit was really to look at why it was that there wasn't more of a national conversation about hospital resilience. And what we discovered was that in the healthcare industry, there'd been a kind of prevailing idea that there wasn't much to be learned from an extreme weather event that wasn't like one you might have in your own region. And so, you know, if you looked at sea level rise and the impact of that on hospitals on the coast, you would say if you were inland, well, that doesn't really have any relevance to me. But what we discovered was that there were really sort of four reasons that hospitals failed. And it was irrespective of whatever the extreme weather event was. It was either that design thresholds for buildings were exceeded. So whether that was the wind speed or the rainfall rate or whatever it may be, that the design thresholds that the codes mandated that buildings be built to just weren't making it with the events that were presenting themselves today. The second one, which relates to design thresholds, is the duration of the events. And that is that we've typically in healthcare believed that we have a 96-hour threshold, that we have to potentially island a hospital campus. So we have a 96-hour fuel supply. We might have a 96-hour backup water supply. But what we saw was that hospitals were being evacuated at the end of those 96 hours because the resupply couldn't make it within that window, either because the event was still going on after 96 hours or simply that the disruption caused by the event couldn't be cured in time to resupply healthcare. And so some owners were sitting back and saying 96 hours isn't going to make it for us. The third reason was really changing geography. And that is that we're seeing these events happening at the edges of regions where they've historically happened, but typically haven't happened so if you look at, for example, Sandy being the classic case of that, there'd never been an event of that magnitude, a hurricane of that magnitude that far north. And so certainly the geography of these events is changing. And last but not least is really utility vulnerability. And I think that that's one that certainly has been demonstrated over the last week or two in Texas, in the Texas-Oklahoma region. And that is that hospitals have typically been designed believing that they can reliably plug in to a utility grid, to a water supply, to a sewage supply, and that if those utilities were disrupted, they too would be cured in this same magic 96-hour period, and everything would come back online. And I think that the disasters that we've seen over the last, really since Katrina in 2005, you might go back to Ike in 2001 in the Texas region, but basically in the last 2 decades, we've seen that these events routinely have exceeded the capacity of the utility to come back online within that specified time frame. And so all that is impacting the way hospitals and hospital campuses are approaching resilience. So today, on this panel that you're about to hear from, we want to talk about a project that's just about to open, actually is in the opening phases, which is the newly built Oklahoma University Medical Center Bed Tower project. And I'm going to turn it over to the panel to really sort of, in the context I just laid out, talk about this project and its resilience response. So I'm going to moderate the conversation, but really begin actually with Casey to talk a little bit about who OU Medical Center is and how you came to incorporate resilience strategies in the building that you're about to open. So take it away.
Yeah, absolutely. Thanks, Robin. Thanks, everyone. If I'm sitting here waving, it's because if I don't move in my office, it turns dark. So I might wave to get the motion sensor going. But so University of Oklahoma Medical Center, we are part of a 3-hospital system here in Oklahoma City. And the Adult Tower, or the University of Oklahoma Medical Center, as it was recently rebranded and renamed, is the state's only level 1 trauma center, and essentially the state's almost the state's only level 2 trauma center as well. We do share that responsibility with the metro hospitals and on a rotational basis. However, we do provide the primary level 1 and level 2 trauma services in the state. And you know, we've been on this project for upwards of a decade plus, but ultimately we're honored and privileged to actually get the opportunity to start construction in November of 2017. The design effort about a year prior to that began again with Tom and the Perkins and Will Dallas team. And I think the conversation came about when Tom and Carrie Garner and others came to our master facility planning group and really came forward with the idea of resilient design, you know, moving past sustainability and sustainable design and moving toward resilient design and what that meant. And we were intrigued by the conversation, by the idea, and in particular as it relates to trauma and what we do and what we serve for the community. And so when you go back to the 90s in the Murrah-Obama building and you look at tornadoes and things like that happen here routinely in large sums in the spring that we're heading into shortly, the numbers of police shootings and just the community that is Oklahoma City. We're a very small community when you look at us on a state scale. And so when things happen in the community that require healthcare services, they come running. They come in droves. Their entire family. It's not their mother or father or their grandparent. It's their aunts and uncles and brothers and sisters. It's everyone. And so one big piece of the initial planning design for our hospital was around how do we accommodate that amount of people that can come should a mass casualty event occur in the metro or in the state. Since all the patients are going to be coming here for the most part, how can we ensure that we're accommodating those family members, those community members that are following? Where can we do this in the most safest way to not impact patient care? Because historically what's occurred is, I'll give an example of a police shooting. When a police shooting occurs in the community, the entire police force plus the numbers of other police forces in the city all come to provide their support. And when they come, their support follows into our emergency department. They fill the halls, the corridors of our emergency room. They fill the corridors of our trauma and critical care areas in our hospital. and it starts creating an extreme, it's just a untenable situation. It's very difficult to maintain and control. And so we created on the front end of our hospital large education conference areas, but that's their day-to-day use. In the event that we must use it, those are able to, the walls are able to open up into the ceiling electronically. We're able to accommodate upwards of 300 people at a given time in that space to really accommodate this issue that we have had year in and year out since really our existence and becoming a level 1 trauma back in the early 2000s. That is just one piece of the resilient design. So then you talk about tornadic activity. We are really in the tornado alley, tornado corridor right here where we sit. We're kind of on the northern edge of it in Oklahoma City, but nonetheless, this tornadic activity, we studied this a lot in the resilient planning and the design planning, looking at wind flows, air flows, how they kind of come into the building, exactly where they're going to go. We really looked at this and how we designed the services and the patient care areas on our inpatient floors in particular, and to focus the resilient design aspects of the terracotta on the exterior, as well as the impact resistant glass that we put in place on our 5th and 6th floors. The reason we did it on our 5th and 6th floors and not our 7th and 8th floors in the new hospital is mainly because those are going to be our ICU level floors. So with critical care patients, obviously during tornadoes, we cannot move those patients into the interior corridors for safety, just because of the number of devices, equipment, et cetera, that they're hooked up to and their instability of their care state that they're in. And so we wanted to ensure their safety, their family's safety if they're staying in there with them, and that impact resistant glass. So a lot of that exterior piece has helped out a ton with that, or will help out if that were to come to pass. I think, honestly, the most important resilient design components that have been put in place, Robin, is exactly what you spoke to, which is a lot around the utilities, right? Our utility systems were circa 1973, back when the building was built originally. And this past week, we found exactly the difference between the two buildings. We saw what the design and the execution of the utility portions, not only our emergency and critical power contingencies that we have, but the domestic water lines that feed our hospital, and how they were designed and set up, created the opportunity of which our South Tower did not have and does not have. And so what happened last week is our South Tower, our city and health science center water lines, our city water plant lost their power and basically dropped all lines, along with all the lines that were breaking just on our campus over by our College of Pharmacy. The lines started breaking, our water pressure started going down. When our water pressures go down, our pumps, basically, once the volume of water is exacerbated, the pumps stop and everything shuts down, and now we have no heat. And so we were in master disaster planning I think Wednesday until about 1 a.m. in the morning, planning to move about 270 patients out of our South Tower because we were losing heat quickly. And so we were planning the locations for them to go. Well, guess where they were going to go? They were going to go to our North Tower, because our North Tower was able to maintain heat. Our North Tower was able to maintain enough water pressure through the systems that were designed and executed on to really keep that population of patients safe. I mean, we were able to continue running our new 32 new operating rooms in the North Tower versus our 4 operating rooms in the South Tower that we couldn't. So all of those design efforts, had we not gone to that diligent level, I think would have put us in a way different position last week than we otherwise were in. So it's done a monumental work for us in really putting myself as the chief operating officer for the facility at ease from having to worry too much about this. The question now is for us, how do we get that back into our South Tower?
And I think, Doug, maybe because this was a lot about utilities and mechanical systems, why don't you give your perspective on the design?
Well, I think, yeah, thanks. Like Casey said, a lot of that upfront planning is really what makes it easier from an MEP perspective. When we're designing these facilities, if you can have those conversations early, like Casey mentioned, Tom and the Perkins and Will team had those conversations early on in the design. And obviously everybody in the design world knows if you make decisions early, you can carry that design through without reinventing the wheel or going back and redesigning areas. And I think that was really part of the success of the project, was that those decisions and those discussions were had early on. A lot, building on what Casey said about the utilities, one thing we looked at it as a design team was the location of these utilities. The generator system is actually tucked up underneath the building a bit to protect it from the elements. We couldn't get it outside and remote, but we were able to protect that utility system. The incoming power to the building is underground, and in an area like Casey said, in Tornado Alley, the threats are different across the country. And Robin, that's what you mentioned. You have to look at each location specifically for the threats that you're going to see in that location. And, being in Tornado Alley and obviously the destruction that's done on the surface with tornadoes, underground utilities are critical. So we were lucky enough in this case to be able to pull our incoming utility power from underground sources. So we didn't have to worry about flying debris, much like it will impact the architectural structure and everything else. So, those decisions were really, really important. And I think, like Casey mentioned, it kind of pays off when you see how that facility was able to maintain function. Internal to the building, we had some decisions that were made early for equipment redundancy, which isn't uncommon in healthcare facilities. There are oftentimes multiple chillers, redundant fans on air handling units that allow the facilities to function. But it plays into that resiliency when you're looking at natural disasters, whether it be tornadoes or in this case, ice storm. The damage on the surface around those facilities is really what impacts their ability to function. And in this case, I think the decisions that were made early really helped us avoid some of the issues that the South Tower there had and other facilities around Oklahoma City probably had.
Okay, and then Julie, I think, why don't you say a little more about the systems? And also, I'm curious for you and Doug to say a few words about the use of Rely and how you can do that. So why don't you start there? Yeah.
Sure. Rely is something that Perkins and Will helped spearhead along with other types of stakeholders in the industry way back in 2012. Kind of like you're talking about, Robin, in 2005 and thereafter, things started happening more frequently and more severely that we knew we had to take notice, and that the codes that were current and all the red tape that comes with updating those just can't keep up with the way that things are now and continue to change and evolve. And so we came up with the first kind of comprehensive resilient design guidelines, which gained national consensus in 2014. And this project was a great candidate to become a pilot project for the guidelines. So it was actually the second pilot project for Rely. And also, Rely has since been adopted by the USGBC. So it's really gaining a lot of steam, and I think people are really recognizing that this is something we need to do. So, for example, it is encouraging us to look beyond meeting code because we know we have to, in the real world. And so, for example, something that we did in terms of the high winds for the tornadoes was designed to 160 miles per hour instead of the current code, or the local code was 120 miles per hour. And there's a number of strategies that we did regarding Rely and taking it through that. And really it creates a level of accountability and just a structure to make sure that you really are thinking about and hitting all the points. But I think that the most valuable thing was, and I think that Casey and Doug, you both mentioned, starting from ground zero at the beginning of the project, what are the priorities? What are we going to try to implement instead of being retroactive about that? And OU actually is extremely stabby with resilient design. When we came into it, generally we're setting up workshops and we're explaining how you talk about what would be most likely to happen and what would have the highest consequence to narrow down the strategies that you want to use or what the vulnerabilities may be that you want to attack. Because, in the real world, everything has a budget and you have to prioritize. In OU, in Casey's group, they had already done a fully detailed outline of what the highest vulnerabilities were. They included ITS failure, pandemics was at the top of the list, and what great foresight was that now that we've been dealing with COVID. Tornadoes, mass casualties, ice storms, and earthquakes. So those were some of the things that were higher on the list that we knew, okay, we need to concentrate on these things. They're likely to happen. And, 2 out of the 7 things I just listed have already happened, and we open fully in May. So I know luckily, we've been able to progressively open pieces of the building along the way. But I think that we were able to make some good decisions with a client who was really in touch, with what needed to happen to protect the people in the building and the building itself. So I'm glad to hear that things went okay last week. And it's funny because here in Texas, and I don't know if Oklahoma is the same way today, but it's almost 80 degrees. It's hard to believe that we were iced over for over a week. And I've been talking to hospitals all week long that are saying they still are suffering the consequences of it, the aftermath that still exists, even though you can go outside in your shorts right now. There was a lot of damage that was done, and I'm glad that this project is so far proven to have aided in that and that kind of extreme weather event.
And Casey, maybe you want to say a few words about the COVID experience and how you think the North Tower, this new tower, is going to perform with regard to that.
That's a very interesting concept. So we early on, the state came to us, the state capitol and the governor came to us back in March or so, April, when COVID was on the rise and just hitting, and asked us and Turner Construction, everyone, could we accelerate 2 of our floors to get it open by June? Mind you, we were on a timeline for day 1 opening in late October of 2020 for at least up through our 6th floor. And we were like, oh my gosh. So we went after it. We started planning that acceleration. Well, then that's about the time that COVID started kind of going down again through the summer months. So here we are coming into the fall. So we made the decision as an organization to go ahead and plan for that second surge. So we accelerated our 5th and 6th floors and got them ready for occupancy, temporary occupancy by September of 2020. We ultimately didn't see the volume fluctuate until October. We opened in October, actually those 2 floors, and moved entire populations of COVID ICU patients over to that new unit. We thought, oh my gosh, this is going to be perfect. We've got windows in the doors. We've got their large rooms, can fit all the equipment, do all those things that we need, gives our teams more space. We have great air handling systems, negative flow. We're going to put in neg air machines within those spaces to ensure we're able to maintain that flow and that safety for our staff. And we thought this is going to be great opportunity. And so as you know, dealing with COVID, or as you may not know, from a healthcare perspective and how you've dealt with COVID and how you manage that population of patients, everything now comes outside the room. So it was identified over time that, well, we don't want to enter the room because we don't have enough PPE and we're constantly having to change. So the best way to actually take care of this population and keep our staff safe is to put extension tubing on all of your medical devices, your curtain IVs and IV pumps, things like that. Move those external to the room. So when we started getting into taking care of patients over there for COVID, we found out quickly how great the design was for our original design intent. The design intent for a COVID population in a unit is drastically different than a design intent for a normal population of patients that have family there and all of that. So our original design intent is meant to be large open spaces, a lot of windows, light, quietness, secure doors. You allow that convenience factor and all of those things into it. very large room. I mean, tripled our nearly 180% of the size of our existing rooms that we have, roughly 363 square feet on each room. And so when our nurse staff got over there, they were like, oh my gosh, we can't hear the patient during a code. We can't hear the team in the room running a code inside the room because it's so quiet. The doors are so quiet. So there's a lot of things that we found out that the design in which we intended, which we executed on, I think pretty flawlessly in the time we had to do it, was great for the original population of patients, but it was not set up to sustain a COVID patient population and environment. They work much better in a kind of a ward, old school ward type unit where you've got a pod in the center and you can turn in a circle right there without having to take a step, and you can see everything right there. All of your team are there, and you're able to take care of those patients. So it helped us alleviate some pressures for capacity levels that we had, but ultimately we found it was a challenging environment.
Doug, Julie, anything to add?
Sure. Yeah, it's interesting too, because I think that you had this centralized nursing ICU unit in your old tower. So part of that too is kind of retraining operationally how you handle that. And then you have this whole crisis going on top of it. So I'm sure that was very difficult to be able to work with that. And I think part of the universal room concept is that you might have that as a med-surg type unit, but with this influx, really all over the nation with COVID, seeing that needed to change to a higher acuity. I'm just curious, Casey, if you had kind of found that to be helpful, or think or foresee that it may be in the future, having the ability to just change the acuity with the universal model.
Yeah, I think the challenge with that concept, without a ton of planning ahead, the difficulty that we ran into and that we're continuing to run into is the workforce component of what universal care means. I think it's simple to create the room and the mechanicals and all of that, the head walls and everything to accommodate a universal concept so that the patient never has to move and you move the care team around them. I think the challenge that we found with COVID was I can't have necessarily my pulmonary critical care team in one area and then have other ICU patients in another area where they're having to go to if I'm downgrading that patient in that room from a COVID standpoint, because then they have to move elsewhere. So we did a lot of work to cohort. And so when you look at universal design, I think the healthcare industry from the workforce piece of it all and the operations piece and the nursing care piece and the providers, we're still trying to catch up and figure out how to do that efficiently and effectively on a continuous basis, because the design aspect's great. I mean, the fact that the flexibility that it's created for us to where I'll tell you an exact circumstance. So we're in today in our South Tower. We don't have the appropriate number of step-down beds, which create a need for step-down monitoring, which creates a need for another level of competent nursing, et cetera, to take care of that population. But in the new tower, I don't ever really have to worry about that because I have rooms that are already set up to handle the additional equipment for ICU level care from an electrical standpoint and a power standpoint, circuitry and all of that. But if I don't need an ICU because I don't have enough ICU patients, well, now I have a ton of step down that I might need. Well, they can also be used as step down beds. So it's going to create a flexibility for us to create an increase of ICU or step down level type beds or decrease that number just depending on what the complement of patients that we have in our hospital at the given time. We are extremely challenged with that in our South Tower right now because we don't have enough step down beds for those patients to go to. So how are we going to figure that out in the future? Well, in the North Tower, we've got the capability to easily place patients in certain rooms in certain areas if we have more of a higher level acuity patient than we do a lower level acuity patient. So I think the design and the intent behind the design throughout and the theme throughout our new hospital was flexibility, adaptability, and that goes into our operating room setting as well. We are extremely flexible in our design intent because we wanted to ensure that we were never hamstrung by a physician, a surgeon saying, I like it this way versus another one saying, I like it this way. And now we're limiting our care area provisions and what we're able to actually accomplish. And so it should allow us to grow much easier. It should allow us to create much more efficient processes, and ability to schedule cases in our operating environment or even placing patients in our inpatient unit environment. So that piece was very intentional and has been very, very helpful for us.
Were you able to use the first floor flexible space as well for the COVID? I know you mentioned it earlier, but because we'd really attempted to have that be able to transfer to either be from mass casualty or even a overflow ED triage, or maybe now COVID waiting room or vaccinations, those kind of things. Have you been able to capitalize on
no,
that?
absolutely. Well, obviously during this time, visitation is at its all-time low. We don't have visitation. We don't allow it. What we do now as things continue to kind of go down, where we allow one visitor at a time. So we haven't needed to use it from that standpoint yet. What we have had to use it for, though, and it's been very, very, very successful for us to streamline our vaccinations of pretty much all of our healthcare personnel on campus. But then even our health sciences, or the University of Oklahoma in Norman has even those employees have come up, and it's allowed us to really be able to disseminate, distribute, and administer the vaccinations in a very quick way, in a high volume way, over the, since the middle of December, since they came out. So we actually set up that entire education corridor space, opened up the walls and everything, and were able to accommodate really the highest volume of patient or of employees, healthcare providers, et cetera, in getting their vaccinations, and really helped our organization kind of get to a point of where we didn't have to worry about our staff being quarantined at home as much anymore and causing further staffing issues for us. So that space has been utilized heavily for that purpose.
So, one of the conversations that often comes up when you start talking about doing impact-resistant glass or making system decisions that offer added level of redundancy or whatever, is how do you make the value proposition for that in a design process where there aren't unlimited resources and every dollar for a building has about 6 possible uses that you can put it to. So it would be interesting for you to talk a little bit about how you made those decisions about hardening the building. And I know, Casey, you said, we hardened the ICU glazing, but not the acute care glazing. Like what did that look like? And, Casey, you could start. Julie, Doug, you could weigh in on the system decision-making that got made along the way. Yeah,
so early on, we had a high-level master facility planning group that really I think the conceptual design intent and purpose of this building and the theme of it came out. We had our board membership be a part of it. We had our state hospital authority and trust partners be a part of the conversation. We had our university partners part of the conversation, and it was really about creating a building that was timeless and could really stand the tests of time, whatever that means. That means change in aesthetic, the change in look, obviously the change in the environment and whatnot that's going on exteriorly. But that was the biggest conversation. And then how did it fit in with the medical district of Oklahoma City, and the innovation hub that has been a part of the Oklahoma City Metro for some time in the downtown area. And so when it came all together and we identified all of these imperatives that the group had, I think that was the beauty of the relationship and the partnership with Perkins and Will, is where they heard those things, and and they took it a step beyond where probably even our thinking was at the moment, which was, well, yeah, let's take it to the next level of resiliency. Let's take it to that, to really create, in the true sense of the word, a timeless structure. And what does that really mean? And I think as those definitions and those things came into the presentation to the group by Julie and others, it created this opportunity that we had that I don't think anybody in that room was willing to say, nah, not this time. This is a once in a 40 plus year opportunity for this campus to build something that's going to impact the entire state of Oklahoma. And what did we want that to say? What did we want that to look like? And I think we executed on it pretty well.
Right. And before you answer that, Julie, I just want to remind everyone in the audience that there is a chat. And so if you have any questions, please post them because we have only about 8 minutes left. So please let us know. And while I'm waiting to see whether you have any questions, Julie, Doug, continue that conversation.
Sure. Yeah, sounds good. Well, we did design it. So we knew, for example, that the Moore, Oklahoma tornado was a big precedent for this job. And of course, there's, like you said, you're right by Tornado Alley, and those things happen all the time. But the Moore, Oklahoma tornado was 17 miles long and over a mile wide. I mean, devastating. So, and people in the room, and it's so important to have all the stakeholders there and to have buy-in and that we all agree with the direction that we're headed, which was great. And people had personal stories of family members, friends, property damage, loss. And I think it really hits home and resonates with people when they're affected. And so we knew that, of course, that was certainly something that we would be dealing with. Not only, like Casey mentioned, the terracotta panels and the missile impact glazing, but there's some strategy because, of course, we're dealing with not only tornadoes, but along with that is high wind and debris and all those kind of things, and the winter weather. So there are some strategies like the glazing that does have a premium that we have to make decisions on where that's going to be most impactful. But then there's other things that we did that we tried to just incorporate from thoughtful design. For example, we eliminated the canopies and have these large overhangs that are soft, and they're strong and that they protect from the elements. We did internal wind studies to understand if that would protect people. We included radiant heating at the entry and the drives to really try to eliminate slip fall risk. Even just coming into the facility. So there's a number of things. When we did again, with what is practical, when we did the wind design studies and how we harden the skin, we know that you probably will have no problems withstanding an EF3 tornado. But if the F5 comes, I mean, and it's a direct hit, there's going to be some damage there, but it would be difficult not to sustain some. And the idea is at that point that you do have the ability to evacuate and get out of there if you need to. But it was important to us to come up with a number of strategies for the things that were most likely to happen and will happen. Because we know that we have to have continuous operation, being, like you said, the only level 1, and being in the business of sustaining lives, that are under your care. We have to. It's imperative to make sure that you can keep going.
Yeah, and I think from an engineering perspective, like Casey mentioned a lot, it's really all about flexibility. And whether you're dealing with the natural disasters or the pandemics, it's about trying to determine the best value that the facility is going to receive or the owners are going to receive for the decisions we make. So you almost have a range of options. And we prepared A3s in this project design and went through a lot of analysis of the benefit for each of those decisions. A small decision on the MEP side, while it may seem small to an engineer or the architects, it may have a large impact on the facility and the way they operate. So I think, going forward, I think what we've learned from the engineering perspective on this is really it's worth the time early on to evaluate those options and determine that range of flexibility that the facility desires. You know, every area, every room doesn't have to have the same level of flexibility, but there are certain areas, like Casey's mentioned, their ICU floor, you know, these different areas in the facility that need to have that flexibility. So being able to separate systems and make smart decisions with systems to accommodate maybe flexibility on floors 3 and 4, but let's make 5, 6, and 7 a more standard layout. You know, there's in the engineering world, we have to be flexible, and we have to be able to see it from the owner's eyes about what flexibility they need and what really makes sense in those system decisions. And I think in this project, everybody really came together pretty well and made those decisions. And, you know, luckily for us, it turned out well for Casey and the facility. And we got to test it early.
Yeah. I'm glad you mentioned the A3 process as well, because basically, for everyone who's listening, if you don't know what an A3 is, it's essentially an 11 by 17 piece of paper with the problem, the proposed strategy, the pros, cons, cost implications, and it's just an easy way for people to get their head around making a decision. So we had a number of A3s that were go, no goes, you know, and that was a really great way to go through the project and determine, you know, what needed to be a priority and what we could lose, you know.
Right.
Well, and I do think that the climate resilience topic is really about what you would call low probability but high consequence events, right? And so if it's an event that has the capacity to take you down, that's a high consequence event. And certainly one of the things that we learned looking at it nationally was that often people underestimate the role that the health sector plays in stabilizing the economic recovery of a city or a place during or after one of these events. And having hospitals go down for extended periods of time often is an impediment to the overall economic recovery of the city or the region because it is such a large employer and it is so stabilizing to the local economy, the supply chain, etc. And so it does require actually all the best decision-making tools. So we only have about one more minute. I'm just going to start with Casey, I think, and ask each of you to do sort of a 30-second one piece of advice to all these people listening to you in undertaking a project your size. In a way, Doug, you already started to answer that by saying it's about really flexibility and thinking about the future differently. But anyone have, like Casey, Julie, add on?
Yeah, I think from the owner's side on creating and designing something of this magnitude, or even not, I agree. I think that where we're at in really the world of innovation and what we're trying to achieve from healthcare industry, we've got to be, and I'm going to take it from Doug, but we've got to be flexible. We've got to be very agile in what we design and create, because we're going to have to be that way in its actual use and the intent. We've got to create those efficiencies. And so I think but Doug said something else that I think what we've had through this project that I think you've got to have to truly make it successful throughout, because it was challenging, no doubt. We had our tough moments, as all projects do, but we had an open dialogue a lot of the time from the very get-go. It was very, very honest. It was very transparent. And I've said this in a number of different events that I've been at with talking with general contractors and architects and others. But we've got to maintain that transparency and that candor and really being aligned with what we're trying to deliver in the end. So alignment, flexibility, adaptability, we've got to have those things.
I couldn't agree more. I think you guys said it all. You know, I was thinking and jotting some notes, and one thing that came to mind, and I think it's already been said a couple of times, is that starting from day one on a project is key. and having overall buy-in from all the stakeholders, having overall involvement from all the stakeholders on agreeing on what the direction and the best or what the priorities really are is extremely important. And then agreed the flexible spaces, because what you're needing typically is not what you needed last week, so, and then you're going to go back to normal days, and then that could also extend to post COVID and what's the next thing. So it's important to always, and even outside of that, just innovation, technology, is improving, things change. So we want to make sure that we are spending our money wisely and that it's adaptable to keep moving with progress and the environment and all those things. So,
Well, that's a good way to end. I think that's a good wrap. So thank you all for coming. We hope this was engaging and useful. Great panel. Thank you very much, and good luck on opening the building officially and getting it all moved in and accommodated. And I look forward to seeing more about it. So thank you, Doug.
Absolutely.
Thank you.
Thank you all.
Absolutely. Thanks, everybody. Appreciate it.
Last session of the day, and thank you. Take care. Bye.
Bye.